Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today I would like to show and share about how to use the software Proficy Machine Edition and Proficy Workbench to create the program and hardware configuration for the PT-300 connect with the remote I/O. Okay. In the previous video, we already learned about how to add the remote I/O. Use only one remote I/O with 4 modules of digital input, digital output, analog input, and analog output. Okay. So today I will show and share about how to configure with 2 modules of remote I/O. With the remote I/O number 1, I will use digital input and analog input, and for VerSaMax or remote I/O number 2, I will use digital output and analog output connect to the port number 2 of CPE. Okay, and for port number 1, I will connect to remote I/O number 1, and port number 2, I will connect to remote I/O number 2. And for remote I/O number 1, I will keep the same as the IP address that we already learned in the previous video. So I just cut the two modules from the previous video, yes. And then I will adjust to be the same here. And for channel number 2 or remote I/O number 2, I will use the new one and need to set the IP address of this module also. Okay, so let's go to our software to hardware configuration and testing of this module. Okay, so first let's open Proficy Machine Edition. And then I will use the existing project that we already learned in the previous video. Here is the existing project. So let's open. Okay, then go to the hardware configuration. For CPE, I will keep the same as the position because the hardware of the PLC, yes, I will keep the same slot, so no need to change anything. But we need to revise the remote I/O here, yes. In the previous video, we have 4 modules of I/O, right? So I will keep only 2, yes. The same as our slide, I will keep only 2 for digital input and analog input. So I will delete analog output, and also delete the digital output. Okay, so I keep only digital input and analog input. Okay, for VerSaMax number 2, I will add more, yes, here. So to add the VerSaMax one more, I will delete this one first, otherwise we will confuse. Okay, So this one keep only AI and DI, right? Okay, we need to use it because we will create more for VerSaMax number 2, right? So no need to delete. So to add one more VerSaMax remote I/O, yes, VS2. Let's go to right click and then go to add target and then go to add the remote I/O, right? So let's go to add the remote I/O. Yes, here VerSaMax Ethernet. Let's go to add target GE Intelligent Platform I/O. Yes, remote I/O, and then click VerSaMax Ethernet. Okay. If we use Profit Bus, we can use Profit Bus. Select the Profit Bus. Yeah. So right now I will select VerSaMax Ethernet. Okay. And I will put the name. Example VS2. Yes. Because VS1 we already use it. So I will add VS2. And I will put the IP address. Yeah. For IP address VS1 192.168.32.2, right? So here I will put 192.168.32.3. Yes. Because the hardware of CPE, right? Okay, this one. LAN 2 192.168.32.1, right? Okay. So we will start from .2 and .3. Okay, I will close this one first. And then go to config. Yes. So the spec of VerSaMax remote I/O is the same as the VS1. Yes. So we need to configure the network and add the module. So for network, I will start from 192.168.32.3. Yes. And for subnet mask is 255.255.255.0. And communication is EGD, Ethernet Global Data. So we must select EGD. And for produce exchange, yes, produce exchange, we can use the format follow the VerSaMax 1. Let's see here. For produce exchange, we can use the consumer, right? Consumer IP address. It start from the CPE. So 192.168.32.1. Yes, because we need to produce from the CPE, right? And here is the exchange ID. Yeah. So we can choose one for exchange ID. And then we need to use the producer ID, right? Producer ID, it means that the Ethernet Global Data ID. Yes. So it will start from 10.0.0.0 here. Yes. So we can basically we can Control C for copy, yes, and then go to paste here, yes, from EGD Ethernet Global Data, and for group ID consume produce, consume period, and update timeout we still keep the same, yes. Okay, and for memory we cannot adjust, right? So we still keep the same, and we can save the project first. So we need to add the card, right? Add the module. So for remote I/O number 2, I will add digital output and analog output, right? So we can add it. So first, let's add the carrier box base. Yes, I will use this model number IC200 CHS022. Yes, and then we need to add the module, right, for digital output. So let's go to digital output, yeah, discrete output, and I will use IC200 MDL750 32 bits, yeah, and it will start from %Q1, yes, and we need to add one more for carrier base, the same, yeah, and then we need to add the analog output card right here. So we need to add the module and go to the analog output, and this is the model number. So we need to choose the model number, yeah, catalog number, the same as our real hardware. Otherwise we cannot test it. Okay, so be careful when we select the model number or catalog number from here. Okay, it will start from AQ, yes, AQ1 and 4 channel. So that's all for config the hardware, yeah, for this module. So we need to download, right? But before download, we need to set the temporary IP, yes, to be 192.168.32.3, right? So before go to set the temporary IP, let's go to set the manual IP address of our computer. Okay, I will change this one to 32 to be the same as the rank of the IP address that we want to set. Okay, and then we need to know the MAC address of this module, right? For this module, we already set it in the previous video. Let me ping 192.168.32.2, right? Let me disconnect the LAN, yes, cable, and then insert to the existing module. Okay, right now I already connected the LAN cable to the existing module. Let's ping again. So if we ping, we can get the reply from the module is okay, right? So if we ping anything for VerSaMax number 2, we cannot ping, right? Because we not yet set the temporary IP of this module. Okay. So let me connect the LAN cable to the VerSaMax number 2. Okay. and then we need to know the IP address, MAC address of the module, right? So to set temporary IP, let's go to right click and then go to offline command and go to set temporary IP address, and we need to fill the MAC address, right? Okay, let me show the MAC address. Okay, go to see the MAC address. Here is the MAC address of the module, right? So we need to know this one. So start from 009991. Yes. So we need to record the address. So start from 0099, then 101. Okay. 101. Yes. Next. 6005, right? Okay. 6005. Okay. Make sure the MAC address that we put here is correct. And then we need to assign the IP address here. So 192.168.32.3, right? Okay, and this is the IP address of our PC. So we can set IP and then click OK and wait a moment for this setting. Okay, it shows like this. It means that we can assign the IP address to be 192.168.32.3 successfully. Okay, then we can ping again. So 192.168.32.3. Okay. Okay, we can ping. And then we can download. Yeah. So right click and then select download to remote IO. Okay. And then click OK. So right now we already download the hardware configuration to the VerSaMax number 2 that we just created. Okay. So we need to download the program, yes, to the CPE also before test. So let me disconnect the LAN cable from this module to the CPE. Okay. Okay, so we need to put the manual IP address to be the same as the CPE for LAN 1, right? Otherwise, we cannot connect to the CPE for download. Yeah. So let's go to change the IP address of our computer. Okay, I will change to .0. And for this one, we no need to change, right? But we need to add more for VerSaMax number 2, right? For VerSaMax number 1, we have only digital input and analog input, right? Digital input and analog input. Okay. So we need to create more for VerSaMax number 2. So So VS2 consume. Okay, I will delete this one first. So produce ID, it should be producer, right? So 192.168.32.3, right? Okay, .32.3 because for VerSaMax number 1.32.2, yes. And for adapter, yes, it's the same because we connect with the slot number 1 or LAN number 1 of CPE, yes. Exchange ID is 2, yes. And timeout, yes. Actually, timeout we can set 603. This one 603 also. And for the run store mode, we can put true because we need to download. We need to add another card and download, but no need to stop the CPU, right? So we can select true. Okay, and we need to add one more for VS2 producer. Okay, and this one we can select unicast, and this is the IP address of destination. It means that produced from CPE to where. Okay, so to 192.168.32.3 produce to the VerSaMax remote IO, yes. And here we can also select true for run store mode. Okay, and we need to add the format, yeah, the same as the VS1, right? VerSaMax number 1. So VerSaMax number 1 we keep only VerSaMax number 1 is correct, right? But the producer no need. I will delete from this one. Delete, yes, because we need to add for VerSaMax number 2, right? So I will add for console first. So double click, and then we need to add to be the same the consume of the VerSaMax number 1, right? So first we need to add the status, and then second we need to add the command, right? For status is 1 integer and command is 2 integer. Okay, so we can go to variables and then right click and then create new integer. So this one should be VS2 consume status, yes. And don't forget select here CPE IO, it means that the project, and it should be 1 for integer. Another one, we need to add the consume, sorry, VS2 consume command, right? Then we need to add the 2 integer for command, yeah. And then we can go here and then click here for add. So for VS2 VS2 status, and then here we can add the VS2 command. Yes, VS2 command, and then we need to add the IO, right? But for the consume, we no need to add, because VerSaMax number 2 we use for produce only. Okay, DO and AO, so we keep here. And then let's go to VerSaMax number 2 for producer. Yeah, we need to add the producer. Let's see here, the VerSaMax number 1 producer, we need also add the 1 integer for status and 2 integer for command. Okay, so for VS2 we need also add VS2 produce status. Okay, 1 integer, and one more for VS2 produce command. Yes, produce CMD, and we need to add 2 array of integer. Yes, then we can go to add. Yeah, here, so here we need to add the VS2 producer status, right? Produce status here, and here we need to add the VS2 produce command. Okay, and then we need to add the IO, right? Because we need DO and AO. So click add, and then add the digital output. Yeah, here, and start from 1, right? And 32-bit. One more for analog. Go to analog output. Here, AQ, and then start from 1. Okay, and it is 4 channel. Yeah, so forward. So that's all for configuration the EGD. Yeah, for VS1 and VS2 produce and consume. Okay, so we need to download. Let's connect to the CPE, and then download the new program to the CPE. Yes, then I will try to plus also. Okay, then I will start the CPU. Yes, so right now it not start, right? So let me change the setting a little bit for here. Consume exchange should be 2, right? Okay, let me change to 2, and then go to the VerSaMax again, and then I will download the hardware config to the VerSaMax number 2 again. So let me change the IP address of computer to 32, and then I will disconnect the LAN cable to connect with this module again. Okay, then let me ping for check. Okay, we can ping. So I will download the hardware configuration again because I'm sorry because confused here. So we need to change this one to 2. For a change for VerSaMax number 1 is 1. Yes. So VerSaMax number 2 should be 2. Okay. So let me set the active target again and then download. To remote I/O again. Okay. Download complete successfully. So I will reverse the LAN cable to be the same position. And then I will set the IP address of computer to be the same position also. So .0. And then go to save the project and then connect again. And I will download again. Okay. And let's test together. Actually, we can stop the CPU and then download the hardware again. Because we change the hardware. Okay, and then we start the CPU. And I will show the status of the PLC. Yes. So let's check the default table. Yes. So right now we got data from analog input. Yes, because right now I already connect the loop calibrator to the channel number 1 of analog input. And this one is for because the existing video we create the program, yeah, for scale analog output, right? Yes, I think here. Yes, we use analog output. So let me show the status. Okay, let's see the status is on. Yes, here for VerSaMax number 1, and for VerSaMax number 2 also on. Yes, here. Okay. Then we can test. Right now I already connected the push button for start and stop. Yeah. And the logic we already created in the previous video. Yeah, here. Okay. So when I push button start, yes, let's see the input is turned on. And relay is turned on also because we already connected the output, yes, to here. Okay. And if we push stop, it will stop. Yeah. Start again. Yeah. Sorry, the button is not connect. Okay, start. The output is turned on. Let's see here. So we can also test the analog. Yeah, here. And right now I already connect the loop calibrator to this channel. Yeah. so we can adjust. Okay, let's see the value here is increase. Yes. Okay, so it worked correctly. So for output, analog output, we can also test from here. Okay, if I set 100%, example 100%, we will got 20 milliamp, right? Okay, example 50%, we will got 12 milliamp. Yes, around 12 milliamp. So we successful configuration this module. Yes. So if we would like to test the control valve or some motor, we can also create. Okay, I will show. So we can use the existing project. Yeah, our project. Yes. We can run our project, the existing project. Okay, then we can set. Yeah, example, I adjust the control valve from here. Example, I will close 0%. Yes, right now the milliamp is show 4. Yes, around 4 milliamp. Let's see, around 4 milliamp. If I adjust to 25%, around 8 milliamp. Yes, 25%, around 16 milliamp. Yes, and 100%, it should be 20 milliamp. Okay. And for digital input and output, we can also create. Yes. So let's go to the main. Yes, here. So here we can also create the motor. Yeah. Example, start and stop the motor. So we can add the point. Yes. Example, I will create for start and stop the motor. Okay, start. I will use %M for start from the HMI. Yes. So I will insert this one. Start HMI. And for the reference address, I can use %M. Yeah, %M1. And for command stop, I can also use the NC contact. Stop HMI. And I can use %M2. Yes. And for digital output, we can also add more. Example, I add to until 8 bits. Yeah, so we can use coin. Yes, coin for 8 bits. Can copy and paste until 8. So 1, 2, 3, 4, 5, 6, 7, and 8. Okay. So here we can use M3 CMD, M4 CMD, M5 CMD, M6 CMD, M7 CMD, M8 CMD. Then we can insert the digital output, percent Q3, percent Q3, okay, percent Q4, until percent Q8, right? Percent Q5, percent Q6, percent Q7, percent Q8. Okay, so we can delete this one. Okay, like this. And then we can save the project and then download the logic to the PLC again. No need to stop the CPU because we just modify the logic. Yes. Okay, right now it's on all because we push the button start, right? So let me stop. Okay, stop all. So we need to stop and start from the HMI, right? So I will add more for stop HMI. It is divide, right? And boolean, because we use boolean. So for stop, it stop from percent %2, right? So let's go to command stop from HMI. This one should be percent %M2. Okay, and we can duplicate for command start. So start from HMI, and this one should be percent %M1, right? Here. And we can change this one for command start from HMI. And then we need to show the status of the output, right? Example, motor 1. So we can duplicate. Example, motor 1 status. So percent Q1, yeah, this one. So this one should be motor 1 status. Okay, and for motor 2 and motor 3 until motor H, we can also duplicate. Just change this to 2 and then duplicate. Change this to 3. Percent Q3 motor 3. We can do the same instruction until motor 8, right? So I will go fast because it's the same procedure. It is just example, yes. Actually, everyone can do any style, yes. Six, 7. Okay. 7 and 8, the last one, right? Okay. So we can create the new screen, or we can use this screen, yes. Edit. I will increase the geometry to be 1000. Okay, too big, right? Width maybe 600, and height should be 600. Okay, like this is okay. This is the existing project, yes. So we need to use the start and stop, right, button. Stop. I will use the color for red. Stop. And copy one more for start. I will use blue color, and the text should be text color should be black, right? Okay, and then I will insert the motor. So let's go to the motor. Yes, we can use another motor that we want. Example, I will use this style. I will use this style. This style. Or this style. Yes. We can use another style that we want. Yes, many styles that we can choose. So I will adjust to be like this for motor 1. Motor 2 should be like this. Then motor 3 should be like this. Okay, many style that we can choose. Motor 4, motor 5, maybe smaller than this, otherwise it's not enough. Or we can adjust the geometry a little bit to be 900. Okay. So we can adjust bigger than 1, 2, 3, 4, 5. Maybe adjust to 1000. Okay. Then I will insert more style of motor. Example, this style, yes. Or this style. 2, 4. Okay, one more, right? I will adjust a little bit more. Many motors, right? So we need to put this one, yes. Okay, I will adjust to be a range again. This one I will change to be this style. Let me choose again. Maybe I will use this style. Okay. Then we can put start stop here and control panel, control valve. Yeah, I will put here. Okay. Then we need to configure the start stop button, right? Okay, for stop button, let's go double click and then go to event and then choose the mount up, new procedure, new, and then choose the absolute set point. And we need to browse the point that we already created, right? So I will choose this. Stop, right? We can search stop HMI and we can copy, yeah, Control C and add more for mount down and choose the new procedure and new and absolute set point again and paste and should be 1, yes. For start we can also the same, mount up, new procedure, new absolute set point, and we can browse start and then start and choose browse. We got start HMI and we can copy and choose the new event, mount down, new procedure, new, and then absolute set point and paste and change this one to 1. So we can save and then test for start and stop. So if we push start, let's see, start, yes, this one on, stop, start, stop, start. Okay, so we need to show the condition of the motor, right? Okay, so we need to add the color animation for the motors. So I will use rectangle, yeah, to put here to change the color of motor, right? I I will use none, and normal is red. So we will change the color, go to color animation and then go to edit. So we can browse the point to be a motor and then start, and we can sort the motors, motor 1 status, yeah. So we can change the field to be green color, yes. When it one should be green. Just copy and then change only this one, motor 2, right? So we can change to 2, and for this one we can change to 3, this one we can change to 4, yes. This one we can change to 5, okay, 5, correct. This one we can change to 6, and this one we can change to 7, and the last one we can change to 8. Okay, that's all. So we can save, and then we can test the screen. Let's see, here is the all motor is turned on, yes. So if I push stop, it will stop, yeah, together because we parallel with the output. And let me show the PLC is on and off also, yes, when we push start and stop. So let's see, the digital output is turned on 8 bits. So if I push stop, yeah, start again, stop again, start again, yes. So we can control from the HMI also for this video. So thank you very much for watching my video, and if everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to request all of you to like, share and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again, and see you next videos. Bye bye.